So the last rule here, basic differentiation rule, is the chain rule, also sometimes called the outside-inside rule, just simply because that's how it seems to work. So once you know the product rule, the quotient rule, and the chain rule, you pretty much know everything there is, that you'll ever need to know about taking derivatives, other than just, you'll run across new formulas periodically. For example, maybe you don't know the derivative of some of the inverse trig functions, but otherwise the procedures still stay the same. So the chain rule applies when you have a composition of functions. So f of g of x, and you're taking the derivative of that. So again, notice this is not a product, the f of g of x, it is a composition of functions. And if you think about it in terms of this outside-inside rule, it says you take the derivative of the outside thing, you evaluate that at the inside thing, and multiply that by the derivative of the inside thing. So I've got a couple of examples here. I'm going to actually start with the one here on the right. I think that will illustrate this chain rule probably better than any of them. So it says the derivative. If you think about the outside thing as being sine, okay, so if you move inside the parentheses, that's the inside stuff. It says take the derivative of the outside thing. The derivative of sine is cosine. We'll leave the inside thing just like it was. So nothing happens to the x cubed term just yet. And then it says we multiply that by the derivative of the inside term, which is 3x squared. And there's really not much simplification you can do here. These two things are not being multiplied. You should think about the cosine of x cubed as being one factor and the 3x squared as being the other factored. So that's all there is to that one. Same thing over here. If it was just plain old x to the 100 power, the 100 would move out front, and that's exactly what happens in this case. And again, we leave the inside term alone. We take 1 away from the power, just like normal. And we're still not quite done yet. Again, this is where we have to multiply by the derivative of the inside term. So the derivative of x squared is 2x, and the derivative of positive 3x is just plus 3. And again, that's your solution. Last but not least, we have x to the 4th plus 7x squared underneath a 5th root. And recall that we can rewrite this as x to the 4th plus 7x squared raised to the 1/5 power. And now we're basically back to the problem we had just a second ago. So just like before, so y prime, the 1/5 will come out front. I'll leave the inside alone. I'll take 1 away from this power. So again, if you're subtracting 1, you'll be subtracting equivalently 5 over 5. So you'll get negative 4/5. And again, we multiply now by the derivative of the inside. So the derivative of x to the 4th will be 4x cubed. And the derivative of 7x squared, the 2 will come out front, get multiplied by the 7, and that will give us 14x to the 1st power. And that's all there is to it. The chain rule is definitely one of the more confusing rules, especially when you have to do it multiple times. So in another video, I'm going to take some more complicated derivative examples, kind of combining all the rules and using some of them multiple times. So it can definitely get long and tedious, but again, when you're going through the process, just ask yourself, should I be using the product rule, the quotient rule, the chain rule, maybe some combination of all three, and then just use your basic formulas, for example, again, the derivative of sine being cosine.